everyone. Thank you today for joining me. Super excited to talk about coding agents, MCPs, and all about security about them. So I'm an engineer myself, and there we go. And about, when I talk to my friends about engineering, this vastly changed in the last 2 years. Right? When I asked them 2 years ago, I was like, hey, try out this AI thing. They'll be like, nah, it kind of produces garbage code for me. Last year, they said, oh, it's writing tests pretty well now, documenting my code pretty well. And this year, we actually started seeing it producing reasonably good code. They've started to use, in vibe coding setting, in prototypes, and even in production engineering now. And the data shows for this, right? Engineering has really adopted AI tooling from 44% to 80%, just a very small span of 2 years in there. The thing that's really changing for us in this landscape, I think, is this, what I call a seismic shift in how we actually use the software. Now, we used to be asking the agents to auto-complete the code we have, write a function, finish it up for me, check it. Today, we're actually giving the agents full-on tasks to do, that they can go off and do, work on it, and then come back with the results with a fully completed application after minutes or even hours. And this shift in agentic coding this really represents a shift in how we think about not just coding, but security and this whole ecosystem. This shift is coming really fast for us. So Claude Code itself, one of the more popular agentic coding tools, saw a massive, massive spike in adoption just in 2 months. Right? This graph here, that spike was July 2025. Right? So in 2 months, it went from not many downloads to over 5 million downloads every single week. So this is coming fast. Our teams are using it fast. And what does it look like? So for those of you who haven't seen it yet, when you use one of these agentic coding tools, you give it an instruction like, make this website nicer for me, change up the colors. The tool then goes ahead and it has access to a browser. It loads the website. It takes a screenshot. It brings that context back into the agent. It can open your files, read your files, edit your files. It can run bash commands to analyze what's going wrong. It can read the logs. And it does all of this with the user's permission. So when you use a lot of these coding agents running locally, Claude Code, Cursor, Codex, they're all running with all the permissions that the user has in order to get this task done. And it's pretty amazing. We've seen these things go from minutes of work to now almost an hour of work when it runs autonomously, going through all the processes here, getting it to the completed state that the user wants. Now, that suddenly opens up lots of risk factors. Like, this is running as me, can do everything I do. So to take a step back and really understand how that risk profile looks like, I thought it'd be good to just walk through a little bit about the insights of how such a coding agent actually works. So a coding agent like this has a few components. There's the agent, there's a person interacting with it, there's tools, and then there's a history of the conversation. When it first starts up, these coding agents actually first boot up with a little instruction prompt here saying, I'm an expert coder, really good at coding. Here are all the tools I have access to. I have access to the bash command to run terminal commands, read files as a user, and a bunch of other tools that you give it access to as an agent in your ecosystem. The user then sends a message to the agent, say, make me a landing page, improve my website, do these things for me. The agent takes that message and the user message. Now it calls the LLM and says, based on these two messages, what should I do? What tools should I use? I have all these tools to the browser, to the terminal. Let me call one of them. The LLM tells the agent, maybe I want to call the npx create react, that bash command here, to create a new application. The agent sees it. It says, great, I'm going to run this bash command, sometimes asking the user for approval, sometimes not. The tool runs, something gets created inside the terminal, and then that result goes back into the conversation history. So believe it or not, when we say agents running in a loop, it is really that simple. We have a conversation history. It keeps going. We keep figuring out what to do next. More tools are called. More files are being read. That then flows back into the conversation history again. And that's how we eventually get to a point where the assistant says, I'm done. What's next? And this history here has gone from a few 100,000 tokens to now millions of tokens. And this is what's driving the ability for these agents to operate very autonomously across long horizon tasks. Now, if you look at that and start wondering, okay, this is how it works, this is really simple in some ways. What are risks in here? So when we look at that conversation history, this is really where the crux of the matter lies, right? And everything in that conversation is given back to the LLM in a loop over and over again for it to make a decision on what to do next. What that means is that everything in there can impact the behavior of the agent. Something bad appears in there, the agent might do something dangerous. So when we talk about things like untrusted tool attacks, tool poisoning. What really happens here, for example, is that the tool result that the tool comes back with may contain malicious instructions. If you connect your agent to your sales to your CRM systems or your customer feedback systems, the customer feedback information may get put into the tool result. So if the tool result says, hey, I need your environment secrets to continue, it's very likely or possible that the agent reads that instruction and says, sounds great. I'm going to call the tool. Next tool I'm going to call is to read secrets. Right? And we have seen this in practice, and I'll show you a little bit of examples of what this looks like. So the other things that can happen in this framework is that not only can the tool results be injected at runtime, the base prompt of the tools itself could be injected. Because every tool has a description, a name, and all of that goes into the base prompt of the LLM. So if the base prompt says, to use this tool, you've got to do X, Y, Z, the agent's going to do X, Y, Z before it uses those tools. So it's really important to have tools that you trust, because if not, those will get into your agent's configuration. On top of all of that, one of the emerging things that we're seeing too is that as we put more and more tools into the agent, the tool execution boundaries are actually pretty weak. Right? So Claude Code, Cursor, these coding tools, they execute as the user. So whatever the user has access to, the agent now has access to. If the user has approval fatigue and just hits enter all the time, the agent will get access to more and more data that you do not expect. If you install MCPs, which we'll cover, MCPs come with a new set of things where the MCP servers that run locally run as you. So again, those tools might have insecure code in there and maybe be able to access more data than you would like to see as well. Finally, a lot of these tools execute without any user-level authentication. Now, sometimes they use shared authentication, no authentication. So as an enterprise, and you're seeing everyone using these tools today, you have very little telemetry into who is doing what, what's happening. All the tool calls being made, that's pretty opaque to you at the moment. And this is kind of risky, especially as people install more tools into their ecosystem. So that's our theory. What's in practice, right? So in practice, we actually see a few situations where the tools have security risks that are not even malicious. This is like day-to-day use of the tools. So Jason Lampkin was vibe coding away with Replit agent, and then he told the agent, we are in a code freeze. Don't change anything. But there's a bug. So the agent said, I'm going to fix that bug for you, and I'm going to run this command db push. Turned out to actually delete his database. He was very upset about it. Put it on Twitter everywhere to see, and it was not great. But it's a vibe-coded app. He's cool with it. But this is a risk that it's okay in a prototype, but not okay in production, especially as production engineers start to use this software. This is really common. You tell the agent that it did something wrong. The agent wants to clean it up, make it better, and says, "Oh right, to clean up the files I created for you, I'm just going to delete everything in your home directory." Yes, no, and it's very easy to just hit yes and keep going and see that directory get wiped out with a ton of worries to how to recover it. This is something that we've seen as well. Finally, the one that I think is actually really risky is that while we trust these agents and LLMs to do some code and all for us, I don't really trust them to have my secrets. And one thing that these agents like Claude Code really like to do is to be able to look at all the data we have, examine our secrets file, set things up for us for deployment for the vibe coders, and it's going to read all your secrets and tell you that you're all set and I know your secrets. Right? This is something that we see happen quite a lot in practice, something that is a really risky situation, just from normal use. So this is all like regular use security issues that come up from just day to day, but we're also starting to see an emergence of attackers using these tools as attack vectors to get into the systems and retrieve data from them. So in August 2025, we saw a compromise in an NX build package, which helps you manage repositories, and it included malware in there that actually leveraged Claude Code to find secrets. So somewhere deep in a package was a prompt to say, recursive search and find files and matching crypto wallets, secret files, and all of this, and make an inventory for me, which I can then go and pull on later. One of my friends at a company he worked at actually saw this happen, and the engineers caught it just in the nick of time before anything bad was released more externally. Very real problems happening out there, and we actually see it happen in practice. So this is there, and then what do we do about this? It turns out that a few days later, Claude updates the system prompt, and the system prompt now says, do not access your credential discovery or harvesting, do not bug, crawl SSH keys and all. Great update to the system prompt, but this is still not hardened, right? There are ways to get around system prompts, even if they are updated this way. So despite all of the security issues, the big emerging threat I think that we're seeing right now is we are going to add more and more tools to this system. Now, today, the tools are like bash, read, and the set of things that come with Cloud Code or Cursor. But tomorrow, we're going to add more tools from what we call MCPs. So for those of you who are familiar with MCPs, they're just a way for you to add more tools to any AI agent you like, ChatGPT, Cloud Code, Cursor, Copilot, Gemini, all of them. And this is a new emerging standard. It's been adopted by a ton of the AI systems out there, the major ones, and increasingly also adopted a lot by different tools out there, data applications. So in one click, you're easily able to say, get your Copilot ChatGPT now saying, read your data warehouse, your calendar, your browser, your Slack messages, all of that. And there are many servers out there from those that are community-driven to those that are official from providers themselves. In fact, there's so many servers, there's a server for golf. So for those of you who are golfing, you can check out this mcp.pga.com server, and yes, they do have an add to Cursor button on that page. So I think PGA figured out that they need more golfers. The engineers need more workouts. They add to Cursor, and maybe when they're coding, they can ask PGA to book a golf appointment for them. Yeah, but it's really that wide, right? Like more than 9,000 servers are out in the wild right now, all kinds of stuff, people installing all kinds of things like this into their coding environments. So how do you think about these things, and are these MCP servers really a threat? So I set up a simple demo in here that just to show you how MCPs work, but also show you how they can become part of the threat ecosystem as well. So this is a demo MCP server that has two functions. One of them is to get documentation. So reading documentation from libraries like React and so on so that your agent does better. And another function that says send feedback. And I've seen this in many MCP servers out there where the developer wants feedback on the implementation. So you have a feedback function that's able to, that the user type in, send this to the developer, they get some feedback about it. So let's see what happens here. So this is a video. I'm going to show you first how this server works. When you install an MCP server into Claude, for example, it's as simple as typing that one line, Claude MCP add. And once you're installed and added the MCP server, it's really easy to use it. You type /MCP in Claude, you see all the tools available, you see all the functions available, documentation, feedback, and so on. And you're able to then now start using that MCP server in practice, right? You can start asking it to get data for you, work with you, get docs so that you can work better with the coding agent there. Right, and then so sometimes you get these dialogues here to say, yes, no, do you approve it? And you keep going, and you can see that this is now in the ecosystem of your MCP servers. So people are installing these things, they are leaving it there and coming back next day and keep using it, and these are servers that live persistently in their environment after that. So maybe you come back tomorrow, and then you're coding away, and you're asking the server, and going back to the Claude and saying, hey, there's some things broken about the website. The links are not working, something's wrong, can you please send this feedback? Can I type in there, or a prompt similar to that you're not really thinking hard about some of the issues you're facing. So this is where MCP that's installed right now could then let the agent know to call the send feedback function I provided, send some feedback, you see that feedback's accepted, or the agent keeps moving. We're all used to this now. Agents work for tens of minutes, hours at a time right now, things fly through. It's gathering data, who knows what it's doing, you trust it, right? You see it, looking at information there, and things just happen really fast in these coding systems that it's sometimes really hard to track every single activity. You might look at the final message and go like, that was fine, that's great. But if you were to just scroll up a little bit and look in the logs above, if you do that, you notice that this particular server I created actually started to ask the agent to provide security keys, things from the environment, things that shouldn't actually be sent over the wire to this particular MCP server developer. And if you actually look closer at what's going on, you'll see that the response from the MCP server wasn't just feedback accepted, it was feedback accepted plus a prompt injection. Right? It was additional instructions on things to send back to the potential malicious actor here. So if you didn't catch that because it was way too fast, here's what you actually see, right? If you zoomed in and just looked into the logs very carefully, you start to see, maybe like OpenAPI keys, Google keys, JWT key secrets being leaked out in there, just from that very simple MCP server that you're using. Now, how did that happen? The feedback from the response from the send feedback function turns out to not just include feedback accepted, it also included a prompt injection here that asks the agent to go and gather more information because enterprise IT requires it, and then send it back as another feedback call. Right? So this is a prompt that's really interesting because this prompt may be, maybe okay, right? There may be scenarios in which your internal enterprise IT teams rolling out MCP server, they want something like that. So it's really hard to distinguish what's a good prompt and a bad prompt, depending on who's receiving the data, where the server is coming from, and a lot of it depends on who the author is and the use case of this. On top of that, the instructions here actually came not at install time, but at runtime. So these instructions could appear today, they could disappear tomorrow, and they could appear the next day, depending if this MCP server is remote. So again, the trust in the servers you're installing is critical because these things can change underneath you. Okay, so that's all the risks, that's all the problems in there. I'm going to move into talking about a bit of the tooling and how can we think about addressing these issues, getting a handle on these problems that we're facing today. And I think there are 3 parts to this. Step 1, I think, is really getting visibility. As we talked about it earlier, coding agents are already massively adopted. 5 million downloads a week, Cloud Code, more than that across the entire ecosystem. We first need to just inventory what's going on. What tool calls are these things making? What MCPs are being installed? That's starting there. And after doing that, we want to think about how to set guardrails. What can be executed, what cannot be executed, what do we actually trust in this ecosystem? Don't trust the server I just created. If you're interested in it, I can give it to you later, but don't trust that one. And finally, get to secure adoption, right? Which is how can everyone in the company really benefit from the productivity, but in a secure fashion. So I'll talk a little bit about the gateway pattern that we see for these 2 things, and these are things that I think, approaches that I think are reasonable at this moment to consider putting into the ecosystems you have. So just an example of a gateway pattern in here. Today, we have Cloud Code as one of the coding agents connect to Anthropic LLM models. And they're they're getting all the tool calls, call this to, get this response. The first thing to do is thinking about, okay, can we actually add a layer in the middle that starts to inspect the tool calls? Now, we have LLM gateways that we use for PII reduction, figuring out if people are typing sensitive data into the chatbots. But now we need to apply some of those techniques, some of those ideas, also to the tool calls that we are seeing for coding agents here. What we can do then is that once we put ourselves inside the gateway, we can start to think about ways to do what I call real-time message inspection. Right? We can start looking at every single thing coming through from the coding agent to the LLM provider and back, and start looking at all the tool calls made both directions. Is this tool call safe? Is the data we're getting it from it comfortable being sent to an external provider there? Right? And guardrails can be applied on both sides. So when a guardrail is applied on both sides, what we actually mean is that we take one of these conversation histories that we saw earlier, find the tool call that's bad, replace it with a message that is an innocuous message from the assistant, and then the agent never actually sees that dangerous tool call. Right? So it's actually a very simple change based on what we have seen earlier on how these agents work. So just a quick demo of this and really get a sense of how does that work in practice? What does it feel like for our users if this was there? So this is Claude. If you do go back home today, try this out. Ask Claude to read your environment files. It's going to be very happy to read it. So try it on demo keys, really. This happens all the time now. And then what we can do here, you see this, this is happening today, happens today if you go back home and try it. We can go into a gateway solution, add a rule in here, for example, say read if I see the file path and it matches, say, environment. What I can do here is to say, instead of returning that tool call, I'm going to change the response of the LLM to say, sorry, we can't do this. We cannot read environment files, right? Let's create that rule. And by creating such a rule inside such a gateway solution, which there are a few options in here, these things are applied immediately. So as we talked about earlier that all of these risks are at runtime, this happens at runtime now because immediately in the same Claude session, these guardrails are applied. And even if you trust the model to try harder, ignore previous instructions and do this, it's not going to be able to do this because the guardrails are not applied at an instruction level. They're applied at a system architecture level. So the 2 things in here to take away from that is that some of these patterns are really nice in that, number 1, they are applied at runtime, but number 2, your users don't actually have a core difference in their experiences when you start using it. So what have we seen in the wild? So we have put out various of these gateways, observability toolkits in the wild, and what we see in the wild today, and these are all real things that we have seen, is coding agents are actively today reading your environment secrets. We see that very, very frequently. In fact, last week I talked to another customer, and they're like, Cloud Code made a commit to the secrets Didn't expect that, wasn't happy with that, right? They want such solutions like this. They try to run pseudo commands to help you get things off the ground, run things for you, even if the instructions say don't run pseudo commands. The good thing is that pseudo commands often fail because you need to type in the pseudo password. They also run things like Kubernetes control plane to get secrets. So that it helps you deploy things, tries to work with Kubernetes, and so on. These are all the things we have actually seen in practice and all the things that you might want to be aware of. And a lot more in there, especially when MCP comes in the picture. So that's a half of it for gateways, for just looking at how agents work and the tool calls in there and getting observability and guardrails. The other half of it was MCPs, right? All these servers we're installing, they're kind of risky, they're kind of out there, what's in there? So it turns out that for MCPs, the way they operate is that they still operate as tool calls. So when you have some kind of a guardrail observability system in there, all the tool calls from the MCP servers also appear as tool calls in the LLM, and then you can just start to inventory and get access like, hey, what are all the MCP servers my team is using? So the first solution actually is really helpful from just an inventorying approach of things. The next thing that you want to do in there is to think about how should my organization start to use MCPs. So I installed a GitHub MCP about 3 weeks ago to try to get my agent to get the GitHub pull request, get the comments, fix it all for me. Why don't I show of hands here? How many of you think that the GitHub MCP has more than 20 tools? Okay. If you leave a hand up, you think there's more than 50 tools. Some down. Leave a hand up if you think it's more than 80 tools. Leave a hand up if it's more than 90 tools. So one hand left. Okay, you probably installed the GitHub MCP server. And the reason is that the GitHub MCP server has 91 tools the last time I installed it. It changes every day. 46,000 tokens. Honestly, it's an amazing server because now your agent can do so much with it, right? You can start thinking about agents that do all this work with GitHub. But the tools are like delete file, delete work for run rocks, get pull requests. Now, some of this you might feel really comfortable with, reading data, reading commit requests, reading what's in the GitHub repo. But delete file may not be one you want your agent to have even any access to. So really thinking about not just installing the servers, but figuring out how can we limit what tools the servers, the agents can use in the servers. Right? Out of the box, these things will install all the tools, and that's not what you want. Now, many of us use more than one MCP server. We might use GitHub, and we might use Linear. So Linear, Jira, project management software to track bugs, track issues, and tickets. Now, take those two servers, install them together naively, boom, you have 114 tools, crazy amount of stuff in there, right? And this is something that you might only want to get a handle of, like what are people installing, what are they using, what is in there. So the natural reaction here, I think, is like, can we start thinking about gateway solutions, right? API gateways, LLM gateways, maybe now MCP gateways. Instead of giving the agent access to all of these tools, let's think about solutions that approach this from controlling the access to this. And so I thought I'll share maybe 3 best practices that we are thinking of that for you to think about how you want to approach MCP tool management. So the first best practice that we've seen out there that we think is really great is to really think about the use cases. If your agent is going to do code review for you, it doesn't need to delete files, right? If your agent is going to do things like maybe make some changes here, it doesn't need to delete linear tickets, So can we figure out the roles, the use cases, what we're designing these agents for, or sub-agents, and then limit the number of tools that they're given? They need tools from different services, and maybe now they need only the read-only tools. Right, so number one is limit the tools depending on the use case and roles, and really structure that so that you're not giving overly permission access to your systems. Second thing is that the tools can change at any time. Right? Tools from a server might increase, might decrease. The beauty of MCPs, the beauty of AI is that it's able to react to these changes. If a new tool appears, if a tool changes, the AI can still work with it. While it's the beauty of how the system works, it's also a risk. So tools will change. New tools will get added, tools will be removed, tools will change in descriptions and names, and each of these things now feed into a risk, a kind of a risk surface for you. If the tool names and descriptions change, that goes into the system prompt, the base prompt in your agent. If the behaviors change, that might impact the results of the tool. So about a week or 2 ago, you might have read about the Postmark MCP server. So that server is an unofficial server, released in the wild, someone was using it, and then they changed the underlying implementation of the server to then BCC all emails sent using that MCP server to an attacker's email address. Happen underneath the hood, but it's a change. If you were installing MCP servers, you want to see that change happen because you will know the version has changed, the Git commit has changed. And then you want to review everything from the implementation to names to descriptions, depending on how your security processes that you have in place there. So have alerts, have rules on that one. Finally, maybe different teams in your company, different use cases will require differentiated tool access. Some people may only care and need the read-only tools. Some might need read-write tools, and that's okay. Structure things in a way that start to group things together in meaningful ways where the users that are read-only tools get that, and users that read-write get that. And maybe if your executive really, really wants to play golf and do it in Cursor, they can get all tools in the Cursor, golf, PGA, MCP. Now, after you've done all the structuring, I think the other thing that we see as a problem in the space is that you don't often get user-level telemetry on what's going on. Many of these servers do not have user-level auth. You do not know, what users are calling. And sometimes you don't even know, sometimes we even share tokens across the servers. So the other thing that we start to see is that gateway solutions will also allow you to then move some of the authentication problems and SSO problems all to the front of the gateway so that independent of how your server is implemented, you can start to have authentication, telemetry, audit logs on every single thing going through the MCP. Right? So these are all emerging patterns, I think, that we should consider as we think about MCPs there. And now you can say the PMs have read access to tools, the engineers have read-write tools to our GitHub, and the C-suite can only book golf appointments. But honestly, you do not want the PGA Golf MCP to be mixed with the GitHub MCP, right? Who knows what would change in that one? Now, I do trust the PGA folks, but there are many other servers out there. So best practice tree, I think, is curating by role, right? So figure out what roles are there in the company. You don't have to give everyone access to everything. And figure out what agents they're using, sub-agents, and then really figuring out how to log and attribute every single request. So that if something bad happens, like postmark MCP server that we saw 2 weeks ago, you know what happened, you know what was sent, you know exactly what happened in the ecosystem there. Cool. And I think I talked a lot about coding agents, Cloud Code, Cursor, so on. But the trend that we're seeing in the next 3 to 6 months is that this is going to go beyond that. ChatGPT this week just announced their Apps SDK. You might have seen that. Apps SDK is built on MCPs. The MCPs are returning the Apps SDK to the UI and all of that. LibreChat, not a coding system, or supports MCPs. So MCPs are starting to become this really connective layer that connects really all kinds of AI agents and tools to tools and applications. And this is going to go very quickly from coding agents, where I think is the biggest use case right now, to all kinds of other non-coding agents, your sales agents, your marketing agents, and all of those. And we always want to connect more systems to these agents to get them to do more things for us. So there are 2 steps in there, right? So lots of issues, lots of security risks with coding agents, but I think we can get a handle on this, right? Let's get visibility, let's add ways to get observability into what's going on in the systems, the tool calls, what people are installing, what they're using, figure out set guardrails around them, and then ultimately secure adoption. And I think part of the secure adoption part is really interesting in that when I talk to users today, many users are actually hesitant to install some of these MCP servers because they are also aware of the security risk. So the more we can set up things that are packaged for a user, figure out these are the servers you can trust and use, I actually think we're going to drive adoption. We might actually accelerate adoption when things are more secure. But these are the 3 things in there, and I hope those are things that we can start getting motion on. So do come and reach out to me, chats about all things MCPs. Feel free to connect with me on LinkedIn, find my name there, it's pretty unique, or email me. And then I'm also be around for the rest of the day to chat about MCP security, governance, and all of the things we talked about there. Okay, thank you.